So a very good afternoon to all of you. So today we are going to discuss the beginning of Fourier series. Okay. So what exactly is Fourier series? Why we are going to use this Fourier series? Okay. And what are the outcomes of this Fourier series? Okay. So before starting this whole topic of Fourier series, don't get afraid by these mathematics. Okay, I will come to this part later on. First of all, we have to understand what exactly the Fourier series conveys to us. The term is written exponential Fourier series. So before starting this part of Fourier series, I want to shed some light on Fourier series. Yes, exactly what is Fourier series? Why do we need Fourier series? And what will be the outcomes of Fourier series? Is it clear to all of you? Yes. What will be the outcome of Fourier series? Yes. So, as this is the first class of Fourier series, some signals are not easy to analyze. Yes. The frequency spectrum of some signals are not easy to obtain. Okay. The various components which are not visible in the time domain can be analyzed very easily in the frequency domain. For example, the bandwidth. The bandwidth of a signal. What can be the bandwidth of a signal? This needs to be analyzed very minutely. Yes, because if the bandwidth is not obtained correctly, then it can lead to a loss in power. So, coming back to our topic of the Fourier series, this expression f of t equals to a naught plus an cosine of n omega naught t plus bn sine of n omega naught t. One thing should be very clear, that this n equals to 1 to infinity. What are these n? These n are the harmonics. The harmonic component, okay, the various harmonic component that are present. I think this is very clear. Upon varying this n, it is quite easy to visualize that we will get different values of an. For example, if n is 1, then this term becomes a1 cosine of omega naught t. Okay. Again, if n equals to 2, then it becomes a2 cosine of 2 omega naught t. Okay. Simply, this thing is also visible, that if we put n equals to 1, 2, 3, then we are sure to get different values of harmonics. For b1 it will be sine omega naught t. For b2 it will be sine of 2 omega naught t. Okay. These things are clear to all of us. Now, coming back to this expression. This is nothing but the trigonometric Fourier series, a basic prerequisite for every engineer, that he should be well aware with the trigonometric Fourier series. Now, coming back to the exponential Fourier series, how we are going to form this Fourier series, this is of utmost importance to all of us. Have a look at this. The cosine of n omega naught t can be expressed as a function of e. Yes, it can be done. It can be expressed as a function of e to the power j n omega naught t, e to the power minus j n omega naught t, something like that. Yes. So it is written as e to the power j n omega naught t plus e to the power minus j n omega naught t by 2. And we are taking this 2 out of this summation. Okay, I think this is quite clear. Now, just for the ease of understanding, I am not showing the limits here, that n is varying from 1 to infinity. But by this summation, I am implying the presence of all the harmonics, that all the different harmonics are present here. Similarly, we can write sine of n omega naught t. Okay, sine of n omega naught t can be written as a function of bn e to the power j n omega naught t minus e to the power minus j n omega naught t, and so on. So n will be varying and we are going to get other expressions. Now what we are going to do is that we are going to collect the terms of e to the power j n omega naught t. Yes, if we collect the power of e to the power j n omega naught t from these two expressions, then it is quite easily visible that this becomes summation of e to the power j n omega naught t half. Okay, an from this term, an will come from this term here, and bn by j will come from the second term. I think this is quite easily evident that this is nothing but pardon me, this is bn by j. Okay, now coming back to the other term, that is e to the power minus j n omega naught t. We can easily visualize e to the power minus j n omega naught t as an minus bn by j. This is quite clear. Yes, this is an minus bn by j. This is half. We are simply selecting the terms, the coefficients of e to the power minus j n omega naught t. Now you can see that this becomes an minus jbn by 2 and this becomes an plus jbn by 2, because j will go up and here also j will go up. So what this term becomes? This is nothing but Cn. Yes, this is what Cn is defined as, the coefficient of exponential Fourier series. Yes, so it is quite easily understood that we can arrive to the coefficient of trigonometric coefficient of exponential Fourier series from trigonometric Fourier series. Now this is nothing but Cn bar, Cn conjugate. You can see, just take conjugate of this term an minus jbn by 2, you are sure to get an plus jbn by 2. This is Cn and this is its conjugate. This is quite clear. Okay, now come to the next part. A naught plus summation Cn e to the power j n omega naught t plus Cn star e to the power minus j n omega naught t. Yes, as I had already told you that we are getting this Cn e to the power j n omega naught t and Cn bar terms. Now see the next line. The next line is Cn equals to half an minus jbn. Now what we will do is that we will put the values of an and bn in this expression. Okay, we will put an in terms of f of t cosine n omega naught t into 2 by t, the expression of an. Similarly, we can also put the value of bn here, that is 2 by t f of t sine of n omega naught t. So when we will put it here and we will solve it, then we will get exactly the same term that we are going to get from this expression. Yes, that's a fact. So by replacing the values of an and bn in these two expressions, we can come to a beautiful conclusion. A conclusion that is very important, and that conclusion is that Cn is equals to Cn conjugate. Cn is equals to Cn conjugate. Okay, I think it is clear. Now, once we obtain the value of Cn and Cn conjugate, we can put those values in the exact summations. F of t c naught plus summation n equals to 1 to infinity Cn e to the power j n omega naught t plus summation n equals to 1 to infinity c to the power minus n e to the power minus j n omega naught t. Now nothing more is left to speak, because you can see that if we move n equals to minus 1 to minus infinity, then this whole terms becomes Cn e to the power j n omega naught t. Okay, now these two terms can be plugged and the summation becomes c naught plus summation n varying from minus infinity to infinity cn e to the power e chain of 1 t. So this is how we have deduced the trigonometric Fourier series from the exponential Fourier series. Thank you.